This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 6, Lesson 7, Quality, Statistics, Control Charts, and Inspection. The exam asks 3 things here. Summarize a batch of measurements, decide whether a process is in control, and know how the parts get measured. We cover the descriptive statistics, build the X-bar and R charts from the sample size constants, run one full control limit problem, and close with the out-of-control tests and the inspection tools. Concept 1. What quality control does. It answers a single question: is the process behaving, or has something shifted? 3 tools. Descriptive statistics condense the data to a center and a spread. Control charts plot those summaries over time and flag a real change. Inspection and instrumentation are how the numbers get measured. In control means only random variation. Out of control means a special cause has entered. Concept 2. Descriptive statistics. The mean locates the data. The range and standard deviation size its spread. The one catch: a sample divides the variance by n-1, not n, because the mean is estimated from the same data. Coefficient of variation is the standard deviation over the mean, a dimensionless spread. Median is the middle value. Mode, the most frequent. Concept 3. The standard deviation family. One sigma spawns several. The standard deviation of a mean of n readings is sigma over root n. Averaging tightens the estimate. The series form multiplies by root n, and independent contributions add in quadrature. That same quadrature rule propagates measurement uncertainty through a computed result. Concept 4. The control chart. Pull small subgroups off the line at intervals and plot a summary from each in order. 2 charts run together. The X-bar chart watches the average, the R chart watches the spread. Limits sit 3 standard deviations from the center line. Inside is random noise, outside signals a special cause. And a key point: these limits come from the process itself, not from the drawing tolerance. Concept 5. The control limit formulas. 2 columns, standards given where you have a target average and sigma, and no standards where you estimate from the data. Most problems are the no standards case. The average chart is the grand mean plus or minus A2 R bar. The range chart runs from D3 R bar up to D4 R bar. X bar is the grand average of the subgroup means, R bar the average of their ranges. Setup. The constants come from the sample size row of the factor table. Read across from your n. Here each subgroup has 5 parts, so A2 is 0.58, D3 is 0, and D4 is 2.11. The problem: 6 subgroups of 5, with the subgroup means and ranges given. Find both charts' limits, then judge a new subgroup. Solve. The X-bar chart. Average the 6 subgroup means to the grand mean, and the 6 ranges to R bar. With A2 from the n=5 row, the average chart limits are the grand mean plus or minus A2 times R bar. That puts the upper limit at 20.23 and the lower at 19.77, centered on 20. Solve. The R chart and the verdict. For n=5, D4 is 2.11 and D3 is 0. So the range chart's upper limit is D4 times the average range, and its lower limit is 0, no lower limit, because D3 is 0 for small subgroups. The new subgroup mean lands above the X-bar upper limit. A single point outside, test 1. The average has shifted, out of control. The coefficient of variation, standard deviation over mean, comes out under 1%. Concept 6. Reading the chart. 8 rules trip an out-of-control signal on 3 sigma limits. Rule 1 is the obvious one: a point beyond the limits. The rest catch what the limits alone miss. Runs on one side, steady trends, points hugging 1 sigma, and stratification. You don't memorize all 8 cold, but know Rule 1 and that trends and runs also signal a problem. Concept 7. Inspection and instrumentation. A chart is only as good as its measurements. Dimensional gauges and the fit limits from Lesson 6 check size directly. Sensors and transmitters convert a physical quantity to a standard signal. Sensitivity is output per input. Repeatability is agreement on repeats. Non-destructive testing finds flaws without scrapping the part. The sensor detail lives in Week 5's mechatronics lesson. This is the quality side recap. Traps. 5 ways this bites. 1. A sample divides by n-1, not n. 2. The constants follow the subgroup size, not the number of subgroups. Read the n row. 3. D3 is 0 for 6 or fewer, so the range chart has no lower limit. 4. Control limits are not tolerances. In control is not the same as in spec. 5. With no standard given, the X-bar chart uses A2 R-bar, not a separate sigma. Quick recall. Compute the grand mean and R-bar. Read the constants off the sample size row. Then the X-bar limits are the grand mean plus or minus A2 R-bar, and the R limits are D4 and D3 times R-bar. Sample statistics use n-1. The standard deviation of a mean shrinks as root n. And the golden rule: a control limit is the process talking, not the drawing tolerance. Next up, Lesson 8, Quality 2. You can now summarize a batch and set control chart limits from the sample size constants. Next, we go deeper on the same data. Process capabilities CP and CPK against the spec. The normal curve yield and parts per million defective and tolerance stack up. Worst case versus root sum square. Everything's at peprepengine.com. Cheat sheet, work solution, and a quiz attached here.
The full study guide with every equation and common exam trap is free at peprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.